radicals, first thing we're going to do is look at what radicals show up on a number line. So we do have 0, and we can make a tally there. So we have the square root of 0 because that equals 0, and we know that. If you go to the right, the next number would be the square root of 1, square root of 2. We don't normally put these on a number line, but it doesn't mean that they are not there. Square root of 3, square root of 4, and you're going to keep going until you run out of room on the right side. Square root of 5, square root of 6, square root of 7, square root of 8, square root of 9. I ran out of room, so I'm going to go on the negative side. Negative square root of 1, negative square root of 2, negative square root of 3, negative square root of 4, negative square root of 5, negative square root of 6, negative square root of 7, negative square root of 8, and I'm going to run out of room there. So these are not numbers you put on a number line, but like I said, they are still there. So on a number line, we have 0, 1, 2, 3, 4 on the right side. Let's see where that would go. 0 is right here. The square root of 1 is 1. Then the next number would be 2, and that would go under the square root of 4. And then you have under the square root of 9, you have 3. So this is what our normal number line looks like, but these numbers still show up in between the whole numbers. So if you come on the negative side, you have negative 1 under the negative square root of 1. Under the negative square root of 4, you have negative 2. And then I ran out of room, but you would have negative 3 if you were able to get that one on your note. Now let's do a regular number line, and you can just go from negative 5 to positive 5. And to start, I'm going to make sure that I have the square roots that go with these numbers. So I know this is going to be the square root of 0, square root of 1, because 1 times 1 is 1. 2 times 2 is 4. 3 times 3 is 9. 4 times 4 is 16. 5 times 5 is 25. I'm going to do the same thing on the opposite side. Negative 1 times negative 1 is negative square root of 1. Negative square root of 4. Negative square root of 9. Negative square root of 16. And negative square root of 25. Now let's go ahead and start the examples. And we're going to be plotting all of our examples back on this number line that you've just made. So here is example 1, and it is the square root of 20. The first thing you have to do is look at your square roots table, your perfect square roots table, and find the two perfect squares that the square root of 20 would be between. Looking at your table, if you find where the square root of 20 would be, it would be between the square root of 16 and the square root of 25. And this is how you should set up your work, because we're going to do something with this tomorrow as well. So it's between the square roots of 16 and the square root of 25. Those are the perfect squares. And then I'm going to figure out which one is it closer to. Is it closer to square root of 16, or is it closer to square root of 25? So I want to know, how far is it from the square root of 16? How far is the square root of 20 from the square root of 16? Well, it is 4 away, because 20 minus 16 is 4. And then if I want to know how far the square root of 20 is from the square root of 25, it is 5 away. Because 4 is obviously less than 5, that means the square root of 16 is closer. So if you were asked, what's the closest perfect square to square root of 20, you would say square root of 16. But then we want to know between what two integers. Integers are the numbers you see on a number line. Between what two integers is the square root of 20, And from that, you can look at your table and find the square root of 16 and the square root of 25. And you know that it is between the integers 4 and 5. Sometimes you will be asked between what two integers is the square root of 20, and your answer would be 4 and 5. We already determined that the square root of 16 is closer, so that means that the 4 is going to be the closest estimate that we could do. And if I ask for a best estimate or the best whole number, my answer would be 4. Now we're going to plot this on the number line. So go back up to your number line. We know it's between 4 and 5 because we already determined that the square root of 20 would be between 4 and 5. So we know it has to be somewhere there. We know it's closer to the 4. So all you have to do to show us that you know it is closer to 4 than 5 is make a little tally kind of in the middle, and you just have to make sure that you put your answer on the side closest to the 4. That tells us that you know it is closer to 4 than it is to 5. So we can make a point, and right above it, we can label it as the square root of 20. For example 2, we have negative square root of 3. So if you look at your table starts with square root of 1, square root of 4, square root of 9, and we know the same thing is going to be on negatives, but square root of 3 would be between the square root of 1 and square root of 4. The only difference is we have the negative symbols in front. Then I'm going to determine which one is closer. So this 1 is 2 away from 3, and this 4 is 1 away from 3. So I'm going to circle, which is what you should be doing because it's a strategy I'm giving you. I'm going to circle the negative square root of 4. And then I can simplify the radicals. Negative square root of 1 is 1. Negative square root of 4 is 2. I'm sorry, negative 2. So you have negative 1 and negative 2. Those are the two integers it's between. If I want to know which one is the best estimate, I would choose negative 2 because I already determined that the negative square root of 4 is closer. So my answer would look like this. Now we're going to go back up to our same number line, and we know it's between negative 1 and negative 2. If we make a mark in the middle, and we know that it's closer to negative 2, we just need to put our number, our plot, closer to the negative 2. And it is negative square root of 3. Example 3 is a fraction. You have the square root of 1/3. If you look at your table, because your table starts with the square root of 1, which is already bigger than square root of 1/3, you know that it's going to be between the square root of 0 and the square root of 1. You don't really have to do the math here to determine which one it's closer to, because obviously it's going to be closer to the square root of 0. And the square root of 0 is 0, square root of 1 is 1, and we know it's going to be closer to 0. So our best estimate, if you had to pick a whole number integer, it would be 0. Now we can plot this on our number line. We know it's between 0 and 1. So here's our number line. We know it's between 0 and 1. Make a mark. And because it's closer to 0, I just have to make sure that my point and label is closer to 0. The last example is negative square root of 17. And I would like for you to go ahead and try to do this one by yourself. So pause it and see if you can do it. Hopefully you were able to get the answer and plot it. I'm going to go through it quickly with you. We know it's going to be between the negative square root of 16 and the negative square root of 25. Clearly it's closer to this one. So it's between negative 4 and negative 5, but closer to negative 4. So our best estimate would be negative 4. Now we can go to our number line. We know it's between -4 and -5, and it's closer to -4. So I made my middle tally mark, and I could put my point, just make sure it's closer to the -4. And that is our final example.